Hello, Internet. C is a language where you manage your own memory, right? Malloc, free, dangling pointers, memory leaks, that's the deal. You get control, you take responsibility. But what if your compiler could offer you a second option, right? Heap allocated data structures managed automatically, no freeing required. This is my C compiler. It compiles C to WebAssembly, and WebAssembly now has garbage collection. That's why I added it to C. The basic idea is this. A normal C program only uses linear memory, a flat block of bytes. You allocate with malloc, free with free, and use pointers to navigate that block. WASM GC types live somewhere else entirely. They're on the engine's managed heap outside linear memory. You can't take their address, you can't embed them inside a normal C struct. They exist in a separate universe. It sounds restrictive, and it is, but the trade-off is that you never free them. The engine handles it. So let me show you what this looks like in practice. You declare a struct with double underscore struct. You allocate with new. Fields start 0 initialized, and you set them with arrow assignment, just like a pointer to a struct in regular C. And that's intentional. A GC reference is conceptually a pointer. It refers to a heap object. The star and the arrow make that explicit. So C23 introduces the auto keyword, which lets the compiler infer the variable's type. And together with the type def, you can clean this up quite a bit. So yeah, it looks nice. Okay, so GC arrays. You declare the type with array int. You allocate with array new, and then you get the length with array len. You can access elements using the usual subscript syntax. You can also create arrays with array literals like this, literal values like this. And this compiles down to the array.new fixed opcode. Okay, so far our containers have had a fixed element type, right? But sometimes you want one that holds anything, like like object in Java, or sort of like void star in C, right? So WASM GC gives you a few choices of types for that, but for us, we're using ecref. So it's a super type of every GC reference type we have, like structs and arrays, and box primitives. And you can also unbox through casting as well. So this turns out to be enough to build some really cool, like generic containers that you usually take for granted in other languages that are just hard to have in C. So here's the heart of a Java-style array list here. And yeah, so this is how you would use it. I think looks pretty nice. And yeah, the full source is in the compiler repo.